Okay, students, so this is a chapter from physics. Name is light, reflection, and refraction. So in this chapter, we are going to study about the one part is the reflection part and the refraction part. This chapter is how a whole chapter is divided into two halves. First half deals with the reflection part, and next half deals with the refraction part. Now in reflection, it is about as usual what you are studying in your low classes, the reflection of light, how it bounces back on concave mirror, convex mirror, and plane mirror. But in refraction, it's something new to all. So it deals with the optical density. It's not very complicated, very simple. Just it's new for you, so you may feel like it's difficult. Very easy it is. So refraction in the sense like you might have seen transparent objects, the light passes, in transparent object like a plastic sheet or a glass slab or water, through water light passes or through oil light passes. So all these transparent objects, the light passes to them, but they have their own optical density, means thickness of that medium. So that changes the amount of light reflecting to that. Now light passing through an object, here we call it as refraction. So refraction means what? The passing of light, or when the light moves from one medium to another medium, that is from air to water or air to glass slab or glass slab to something else. From transparent object, the light bit it bends. So that we will not go now. First we will finish off the reflection part, then we will go to refraction part in detail. Okay, so in reflection part we are going to study this using two types of mirrors. One is called as concave mirror and another one is called as convex mirror. So here it is. So this is called concave mirror because it's like cave. Inner part is reflecting. So it's called concave. Now convex mirror. Here the bulge on the outer surface is reflecting. Here inner surface is reflecting, here outer surface is reflecting. This is concave mirror, this is convex mirror. Okay, don't get confused with this. And in this chapter we are going to study about three new representatives, that are C, F, P and small f. Okay, so this C means center of curvature. We call this a center of curvature. I'll explain why we call it a center of curvature. And it's called principal focus. And this is called pole. And this is called focal length. Now they all have some reason why they're called like that and where to use those terms. Now let me explain. If you think of a ball, like a football, spherical object. So it's a spherical object, okay? So the center, every circle will have a center. So this center here, this C comes, center. So this is called center of this curvature. So center of curvature is this C. C means center of curvature. Now next comes focal length. Now from here if you draw a line, a radius. So this radius is nothing but focal length. I hope you can see this clearly. This is small f, okay? This one, small f, focal length. This is center of curvature because center of this curvature. And now this is a principal focus, no, pole. Okay, this pole is the point where this meets, P. Here is the pole. Now you might be thinking, what is this spherical? So actually we are dealing with the spherical mirrors, right? Concave, convex, concave mirrors, convex mirrors. They are spherical mirrors. Why they are called spherical mirrors? Because a hole is a sphere from which a mirror takes a part. So this is a concave mirror. I hope now you got it. Why we call this a center of curvature? What is the focal length, focal length, and pole? Well, here you call the X, Y. They are simply X. You call them axis. So this is a concave mirror. In this here comes center of curvature, focal length, pole, xy. These are simply representatives of the top and bottom. Okay. Now where does this comes is when you might have seen in binocular glasses that all the rays when they pass through the glass they meet at some point. Okay, so here it happens same. When many rays fall come parallel to principal axis. Now this is called principal axis. Principal axis. So when many rays come parallel to this, they come bounce back, they reflect back and meet at some point on this pole. So at some point it meets. This is called principal focus. Means all the lights get focused there. So here comes principal focus. Okay. Now we'll move to. I hope you guys have clearly understood this part. This is called principal focus because when the rays hit the mirror, they get focused at some point. That point is called principal focus. This center of curvature. This is called principal axis. This is called focal length. This is pole, and this is x and y representatives of top and bottom. This is concave mirror. So same it is for convex mirror, but for convex mirror it is like how okay. So if mirror is on the outer side, but these terms are on other side. Okay, so mirror is on this side, okay, but these terms are not on this side, they are on other side, the behind the mirror. If this side is mirror, behind these terms come. This is principal axis, principal focus, center of curvature, focal length, this is pole, x, y, representatives of top and bottom. This is convex mirror. Now before I showed off concave mirror, this is convex mirror. Okay. Now let's go to the rules of reflection. There are 4 rules of reflection. Is how the light reflects. Means when it hits at this point, how does it reflect? When it hits to that point, how does it reflect? So like there are 4 cases. Okay. Now 4 rules. Now let's go. Well, these rules, they are same for both concave mirror, convex mirror. Well, to explain, I will be using concave mirror. Well, the focal length actually we don't require it now. So I have not written it because we don't require it now. Only when we go to numerical problems that time we require the focal length, the small f. Focal length. So now we don't require, so I have not written it. Now the first case is when the light travels parallel to principal axis. Now this is our principal axis. Now the light travels parallel to principal axis. Then when it reflects, it passes through focus. These arrows are very important, okay? So it passes through focus. I hope you can see clearly. This is capital F, okay? Focus. When the rays travel parallel to principal axis, it after reflection they pass through principal focus. Okay? This was the first case. Now it's not very complicated, okay? Very simple. This chapter is only very simple. You can score easily. Concentrate properly. So this is first case. That's it. Now let's go to second case. Okay. Now second case is that here in the first case you saw if the light travels parallel to principal axis, it passes through principal focus. But what if it passes through principal focus? So we will study first if it passes through principal focus. See here incident ray is passing through principal focus. Then after reflection, vice versa this. it will travel parallel to principal axis. Here same like this only, but here after passing through principal focus, after reflection, it travels parallel to principal axis. It's a reflected ray. It travels parallel to principal axis. Okay, that's it. Second case. Now third case. Okay, so the third case is that what if the rays passes through center of curvature, that is C, center of curvature. So what if the rays pass through this? So if the rays pass through this, then after reflection it reflects back in the same path. So this is reflected ray, so incident ray, this is reflected, instantly reflected. It reflects back in the same path. It doesn't change path. So when it passes through center of curvature, it reflects back in the same path. Okay. Now let's move to fourth case, last case. Okay. Now what if the line hits the pole, directly to the pole? So what happens is that when the light hits incidentally, when it hits directly to the pole, so it reflects back similar to the incident ray, where angle of incidence is equal to angle of reflection, and the principal axis becomes the normal between the incident ray and reflected ray. The normal is the principal axis. So this becomes the angle of incidence, and this becomes the angle of reflection. And as you know, angle of incidence is always equal to angle of reflection. So here principal axis becomes the normal. Okay. So the same cases are applied for convex mirror also. Nothing changes in this. Same it is for that also. So but I'll show you the first case how it is. Just for some idea. I want you to get some idea about it. So about convex mirror. Okay, so here this is the mirror. Okay, this is not the mirror. This side is the mirror. The terms are behind the mirror. Okay, so if the light travels incidentally, if it travels parallel to principal axis, means you can see principal axis and incident ray are parallel. So what happens is that the light reflects this side. Yeah, mirror is this one. It should reflect other side only. But if you reproduce that line backward, it passes through principal focus. Now in concave mirror, what we saw in the first case, if the light travels parallel to principal axis, it passes through principal focus. So here it has reflected, but when you reproduce that line backward, you get it to be in the principal focus, at the principal focus. Now I'll show you this next case, second case. So here, if the light passes through principal focus, then it travels parallel to principal axis. That was our second case in convex mirror. You can check in textbook, they are mentioned clearly. So if the light travels through principal focus, that is like this. Okay. Now think it's not passing through principal focus. How can you say, sir? It is passing. Because if you reproduce that light, it passes through principal focus. But actually this side is a mirror, other side is not reflecting. Only this side is reflecting. So we have to assume that it is passing through principal focus. Because the light cannot pass through mirror, you know. So it travels parallel to principal axis. The principal axis and in a reflected ray, both are parallel, because the incident ray is passing through principal focus, not directly, but we can say because it is at this position. So when you reproduce, you will get it to be passing through principal focus. So in such case, the light reflects parallel to principal axis. So this is similar to our second case in concave mirror. About the third case. Okay. So what if the light passes through center of curvature? That was our third case in concave mirror. So let's see what happens in convex mirror. Now light. It is when it hits here, the incident ray is when you reproduce it backward. It should be passing through center of curvature when you reproduce it. So in such case, what happens is the light reflects on the same path. So incident ray, reflected, both in the same direction, means on the same path. The path doesn't change. So this is our third case in convex mirror. I hope you guys understood why did I draw this dotted lines. It's just to represent that if here the mirror could not be there, then it could have hit the center of curvature. Just to show this, I have put this dotted lines. So in such case, the light reflects in the same path. This is our third case. Now let's move on to the last case, the fourth case. Here, so when the light hits the pole, so you have to consider, if you reproduce this principal axis on other side, it acts like a normal, not a ray, normal between this. So this becomes angle of incidence, this becomes angle of reflection. So this becomes the normal between the angle of incidence and angle of reflection. So these are our four cases in concave mirror and convex mirror. Now let's move to the next one. I hope it was not that complicated, you know. Okay. So in this video we are going to teach this much. I'll see you in the next video. Bye bye.